At the Langley Research Center Transonic Dynamics Tunnel, a study of the buffet and flutter characteristics of the Saturn Apollo vehicle has been conducted. The model program was managed by the NASA Manned Spacecraft Center as part of the development program for the Apollo vehicle. The dynamically scaled model was designed and fabricated by the Los Angeles Division of North American Aviation, with technical assistance by the Langley Research Center. The completely assembled model was approximately 14.5 feet long and weighed 786 pounds. A central aluminum tube provided properly scaled stiffness distribution and the necessary strength to resist the loads imposed during testing. Styrofoam segments attached to the aluminum core provided the correct external contours. Lead weights, which provided the correct mass distribution to simulate the full-scale vehicle at the Mach 1 point in the launch trajectory, were attached to the aluminum core beneath the styrofoam segments. An electromagnetic shaker was used to excite the model in its flexible modes of vibration during portions of the tests. The moving coils of the shaker were attached directly to the inside of the model. The model was supported on a sting, which carried the fixed field coils of the electromagnetic shaker. The model was mounted to the sting by means of a system of leaf springs, cables, and torsion bars. The leaf springs were utilized to take out drag loads and provided approximately 25% of the pitch stiffness required to simulate the full-scale rigid body pitch frequency. The model weight was supported by cables attached in a manner to minimize restraint imposed on the elastic deformations. These cables were routed along the sting, then out the rear of the model and up the sting support strut to a mechanism which provided the rest of the required pitch stiffness by means of torsion bars acting through sector arms. The other end of the torsion bars could be rotated by electric motors so that the model position with respect to the sting center line was continuously controllable. The resulting support system provided for simulating the full-scale rigid body pitch frequency with a minimum of restraint imposed on the elastic deflections. These deflections of the model were recorded in terms of bending moments by means of electrical resistance type strain gauges located on the aluminum tube in the model. Prior to testing, the model was subjected to sinusoidal excitation. The apparent irregular motion is due to camera stroboscopic effect. In addition to the basic model, several modified nose configurations were tested. The basic configuration was tested with and without a flow separator disc on the escape rocket motor. Then tests were made with the escape tower and rocket motor removed completely. Finally, the Apollo capsule was replaced with a Jupiter nose cone. The test program consisted of determining model response throughout the transonic speed range at angles of attack up to 6 degrees and measuring the aerodynamic damping over the same range for the basic model and the modified configurations. Signals from the model pickups were monitored and recorded on tape for later analysis. The data obtained from the model tests were then used to estimate bending moments that would be produced on the full-scale vehicle by aerodynamic forces due to buffeting.